Hey, good morning, Denise. How are you doing?
Marvelous.
Excellent. Where is everyone? It's just you and I here today.
Well, what's up with that?
Yeah, I don't know. I hopefully more people will join us as we go along, but if they don't, that's all right. We're still going to have a party.
Yep. Only
So
takes two, right?
that's right. You feeling okay with your studying?
Oh, yeah.
Good, good. Okay, well we're ahead of schedule with what we had been doing with our mechanical ventilation lectures. So we're going to get into some questions today, and then I will probably end up preparing more information question-wise and whatnot for our week 4 lecture. So right now that's kind of up in the air with what we'll talk about next week.
Okay.
But this should be a good day for us. Are you comfortable with assist control, SIMV, CPAP with pressure support? Do you want me to go over any of that again as a review?
Yeah, can you just like review, just touch on the high points?
I would be happy to. Let's let me just get to a blank screen here. Okay, let's go ahead and start drawing here. I have to
Your
turn
favorite.
the pen on. Let's see. Okay, so up here we're going to have assist control, CMV, controlled mechanical ventilation. I just always say assist control, but we have that.
That's the way it is on the test as well.
Yeah,
It's AC.
and I'm so used to saying it like that that it'd be hard to get me to change. Okay, SIMV and CPAP with pressure support. Okay, let's draw some windows here where this is not nice and straight, but okay. So first of all, we know that the windows are going to be as long or as big of a window as they need to be based on the respiratory rate. So if we have a respiratory rate of 10, that means each window will be 6 seconds long because we just divide 1 minute by 10, and that gives us 6 seconds per window. Okay, and I talk about the windows just because we need to make sure that we have enough time to exhale. You know, it deals with our IE ratio, but also it's good to show you the differences between these when I draw the windows. So assist control, if we are on a respiratory rate of 10, we're just going to say respiratory rate of 10 for the SIMV also, we are going to have one machine-driven breath every time we get to a new window. That's just what the ventilator does. It says, okay, you can have 10 breaths per minute. That means that I need to give you a breath every 6 seconds. Okay, and guess what? It's the exact same thing with SIMV. They're both on the same rate. You're going to have a machine-driven breath every 6 seconds in this situation. And so if your patient is riding the vent, they are not breathing spontaneous in any way, SIMV and assist control will look exactly the same. They will both deliver one machine-driven breath every time we get to a new window. Okay, now CPAP with pressure support, it would just look like a straight line going across if the patient's not breathing spontaneous, because what it's trying to do is just keep your pressure at whatever the CPAP is set at. Okay, so let's say in this situation, let's say CPAP of 5, pressure support equals 10, and that means that our peak inspiratory pressure would be equal to 15. Okay, so the difference comes when we breathe extra in the window. So if we start over breathing the ventilator, Every time you overbreathe the ventilator, you're going to see that negative deflection. First of all, that shows you that the patient took a breath and that decreased the pressure for a split second. And then the ventilator kicks in and it gives a full machine-driven breath. Every single time. And you can breathe as fast as you want, as long as it's physically possible to breathe that fast. And every single one of those breaths are going to look exactly like each other when you're in assist control. Okay, if you are in SIMV, the first breath in each window will look just like assist control breaths because it is an assist control breath. But the other breaths are going to be pressure support breaths. And they're usually smaller breaths like this in comparison to the machine-driven breath. And so you can start seeing a difference with SIMV versus assist control once we start overbreathing. Oops, sorry, that's supposed to be a big one. Once we start overbreathing the ventilator. Does that make sense?
No.
Okay, that's all right.
Now, I know with the assist control and you have your negative when the patient triggers the breath and it goes into the mode. But with the SIMV, they're not getting the volume. I mean, why is it smaller?
Okay, that's because, let me write this out up here. Okay, machine driven breaths, meaning that the machine is doing all the work.
Right. So you'll set like a tidal volume and the machine gives it to them every time, regardless if they instigate it or not, right?
Exactly. You are perfect on that. That's right on target.
Okay.
Okay. This, I'm going to write the same thing here. Machine driven breaths.
But now these are breaths that the machine will give you one every 6 seconds. But if you take your own, you're only breathing in like a 200 tidal volume or whatever tidal volume you take in.
Yes.
It's not giving you that extra.
Right. So it's not giving you an exact volume, but what it's doing, okay, so these machine-driven breaths, it is giving you an exact volume. So let's say we have 500.
Okay.
Okay, so that means this is 500 and this is 500 and all the way across, they're all 500. Okay,
Right.
and in here we'll say tidal volume equals 500. So here we have 500, here we have 500, and so forth. These smaller breaths are pressure support breaths. So we can adjust these up or down. They don't have to be small like that. They usually are smaller than the volume breaths. But what we've done here is we have another mode that we put on. We say pressure support equals whatever we want. Let's say 10 in this situation. So that means if this is a pressure of 5, so that's sitting at baseline, a PEEP of 5, and then we go pressure support breaths, that means that this is a pressure of 15, and this is a pressure of 15. So you'll notice that these pressure support breaths are similar to if we were in pressure control, because we are controlling those by a pressure, not by a volume.
So how would you know if you're in a SIMV mode, how would you know that the patient needs pressure support?
Because you're going to look at the return tidal volume from those breaths, and you'll adjust your pressure support to get a tidal volume that's acceptable for you. Whether it's 6 cc's per kilogram or whatnot.
Okay.
So here's the thing. Let me talk to you about it in terms of CPAP for a minute.
Okay.
So when we have a patient at our hospital, our physicians aren't big fans of SIMV. They say, look, you're either ventilating this patient and breathing for them, or else you're weaning the patient. Which one are you doing? If you're ventilating the patient needs that support, keep them in that assist control or whatever mode we have them in that's giving them the full support. If you're weaning the patient, put them in CPAP. And so that's what we do. So I'm gonna draw a line here at the bottom, and we'll call this a CPAP of 5. Okay. So that's what the breath is going to be. That's where the vent's going to keep the patient all the time as long as they don't breathe. It's just going to keep them at that CPAP of 5. Okay, similar to a CPAP machine that a patient wears at home for sleep apnea. But then we're going to say, okay, pressure support equals 10. So let's come up here and let's say 15 is right here. And here's 10. So they're sitting here at baseline, and then they take a breath in, and it says, oh, I need to give you 10 of pressure support. That's on top of the PEEP. So I'm gonna put the pressure up there, and there's your breath. Okay, now let's say pressure support equals 20 in this window. Then you would see the breath coming up higher, because it would be coming up to, or sorry, PIP equals 20, pressure support equals 15. So it would be coming up to 20 in that situation. Or maybe I want to go pressure support equals 5. So you'd have a smaller breath because it'd only be coming up to 10 on the pressure, because 5 of PEEP, 5 of pressure support equals 10. Okay, so if I am in assist control, I'm coming back up here and let's work in the second box for a second. I have this set at 500 cc's, right?
Yep.
Okay, but I can look at the ventilator and I can see what the peak pressure is. Even though I'm not setting the peak pressure, I can still see what it's achieving. So let's say this peak pressure is 22 centimeters of water pressure, because I just looked at the ventilator and it's monitoring all the different values. And I looked at the peak inspiratory pressure and I saw, oh, it's 22 centimeters of water pressure. Okay, so in this situation with this particular breath, I can see that the patient got 500 cc's and it was at 22 centimeters of water pressure. If I wanted to mimic that pretty close going to CPAP, I could say, okay, peak pressure was 22. 22 minus 5 equals 17. That means I'm going to set my pressure support at 17. And now when I give a breath, I'm at 5 already, and I come up to this part right here, which is 22 centimeters of water pressure. And there's a good chance that this is going to be roughly 500 cc's of volume.
Okay.
Is that an okay, it makes sense, or is it okay?
No, that makes sense.
Okay. Because we know that we can set one or the other. We can set volumes or we can set pressures, depending which mode we're in. Okay, but if I'm setting a pressure, there's still a volume associated with that. And if I'm setting a volume, there still is a pressure associated with that. Whatever pressure it takes to get that volume in is whatever pressure it is. So even though I'm up here, let's say up here in this assist control, and I'm setting a tidal volume of 500, well, it's really easy to see what pressure it takes to deliver that 500.
I think what really confuses me is that you have all of these, like the PEEP and the PEC and the all of them mean the same thing.
Mm-hmm.
And I think that's what throws me off a lot.
Okay.
Is like what you just said, up on your assist control, you get 500 tidal volume, but you peak out at 22 centimeters of water pressure. Well, peak out is the same as peak inspiratory pressure. I mean, that's where, I think that's where I get all confused.
Okay.
Is that
So,
all these things mean the same?
yeah, so peak pressure and peak inspiratory pressure are the same thing. On the test, it will say, I believe it says peak pressure for your TMC exam instead of PIP.
Right.
So, but just know that there are specific pressures involved. And yeah, there are. That's why at the beginning, I try to emphasize the difference between PEEP, peak inspiratory pressure, plateau pressure, because there are a lot of different pressures we're talking about, and we need to make sure that we know the differences and how they relate with each other and
Right.
whatnot. So
Because correct me if I'm wrong. Now, when you go to your I know I'm kind of off a little bit, but when you go to your plateau pressure, I mean, that's actually your hang time and your mean airway pressure.
So mean airway pressure is different than plateau pressure, and I can go over mean airway pressure and explain it to you. Plateau pressure is what we use to measure the static compliance. That's what we use to measure the compliance of the lung.
Right,
And
but isn't it at the top up there? I mean, when you take a breath and you set an I time of the time that you want it to stay there.
yeah, so a plateau pressure, if I'm going to draw real, I would come up like this, and then it drops down just a little bit like that.
Right.
And so this would be your peak inspiratory pressure. This would be your plateau pressure.
Okay. Yeah. Okay.
That makes sense?
Uh-huh.
Because your peak inspiratory pressure is the pressure while the air is moving, and so it incorporates airway resistance into it. It's because we know that we're going to have resistance to air movement. That's just how physics is. We can have a lot of resistance, we can have a little bit of resistance, but there is always going to be a resistance to airflow.
Okay.
So that's added on to it. It's measuring that. And then when the air stops and you don't have any air movement, then it's measuring that pressure also, and that's where it drops off a little bit for your plateau pressure.
Okay.
Okay, so on this example here, up here at the top, we're in assist control, and we're delivering tidal volume breaths every single time. The machine is giving it, even if the patient only wanted 200 cc's, the machine's still going to give them that 500 cc's that's set. When we come down here to CPAP, we are dialing in whatever kind of breath we want, a big breath or a small breath, depending on how much pressure support we give them. We can adjust it up or down. So, for example, if I'm switching a patient from assist control to CPAP, I'll start up high with a high pressure support. I might start at 20 for pressure support. And I'll just look at the ventilator and I'll say, how big of a tidal volume am I getting in return? If I'm getting too big of a tidal volume, I'll decrease that pressure support until I get the tidal volume that I want. So basically, we're just adjusting how much support we're giving that patient.
Okay. Now on the exam, I mean, I've noticed that some of the answers are add pressure support.
Okay.
When would you know to add some pressure support?
If you need to increase the tidal volume.
Okay.
Because the more pressure support you give, the bigger your tidal volume is going to be.
And pressure support is ventilation.
Well, pressure support helps give or helps us blow off CO2s. Pressure support would be equal to adjusting the tidal volume, which, yes, does affect ventilation.
Okay.
So now when we come back to the middle section there, where we have SIMV, the reason why I've drawn those breaths smaller is to show that they are pressure support breaths at whatever we have them set at. If I want those to get bigger, I would increase the pressure support. And that would make those pressure support breaths bigger.
But then if you had to do that, you just might as well have them in an AC mode or put them on a CPAP.
Yes, in a lot of situations that's true. However, the patient, it's harder for, there's a higher work of breathing associated with a pressure support breath than there is an assisted control breath that's completely given from the ventilator. Because the pressure support breath, the ventilator only gives you that pressure support while the patient is actively trying to breathe in that air. So here's the difference. When you're in assist control and that patient instigates a breath, they're going to get the rest of that breath no matter what, unless they hold their breath or something or cough against it and it increases the pressure too high. But the assist control breath, it will give the entire breath, even if the patient didn't want the entire breath. Pressure support breath, it only helps you while you're helping yourself. So if I want to take a small breath in, I just want to go like that, it'll give me pressure support while I'm doing that. But if I wanted to take a bigger breath in, I could go like that, and it would help me all the way while I am breathing in. It just increases. It's like BiPAP is what it's like. You have an inspiratory pressure and you have an expiratory pressure. The expiratory pressure is the PEEP. The inspiratory pressure is the PEEP plus the pressure support.
Okay.
So I can tell that it'd probably be good for me to talk about pressure control just for a little bit because of the concepts that we're talking here. So if we're up here, let's see, volume control, assist control, pressure control, assist control. So pressure control down here, volume control up here. Okay, volume control, you have a set flow and you have a set tidal volume. Okay, your breath goes in just like that. We'll call it 500 cc's, and that's what you get. Pressure control, you have variable flow. And you set the pressure. So we can have a breath that comes in like this, and we'll call this 20 centimeters of water pressure. And you have a set I time. So we'll call this the I time. Oh boy. I time. Okay, so once it gets to that pressure, then it will just hold it at that pressure until it gets to the I time, and then it will exhale. Okay, so differences between these two, you can see the I time is a difference for certain. This is a set flow. It's like up here at the top is like breathing through a straw. This gives you whatever flow you want. And pressure equals whatever is set. Okay, we know that there's a certain amount of volume under this curve, just like there's a certain amount of volume under this curve, right?
Yeah.
We also know that there is a certain pressure right here, which we have set, but we also know that there's a certain pressure here too. Right? Because we have a thing on the side that'll say, you know, what the pressure is. Does that make sense?
Uh-huh.
Okay. Now I'm going to go back a screen. guess what? These are volume breaths. These are pressure control breaths. And that's what SIMV is. It's a marriage of assist control and CPAP with pressure support. But pressure support breaths are like pressure control breaths. It's a variable flow, and you're setting a pressure instead of a volume. Okay, don't let that confuse you. There's still an associated volume with the pressure. We've seen that. We saw that on the last screen we were on. Okay, but what we're doing here, if we want to wean this patient, let's go to another screen. If we want to wean a patient in SIMV, so here's assist control, here's SIMV. Assist control, there's your breath, every window. Okay, and all your extra breaths. Okay, that's not weaning a patient. That is giving them all the support that they want. Okay, SIMV, what we can do is, okay, let's say we have a respiratory rate equals 12. Well, SIMV, what if we drop the respiratory rate down, let's say equals 6. So you can see those machine-driven breaths, but now the rest of these are pressure support breaths. Can you see how the patient's doing more work with this?
Oh, yeah.
And that's a great thing about SIMV, because we can drop that mechanical ventilator-driven breath low, and then we can adjust the pressure support up or down, whatever we want, to offload as much or as little of the work of breathing onto the vent. And so basically we can just adjust how much support the patient's getting. If they need more support, that's fine, turn it up. But all of a sudden, maybe we're at a pressure support of 10, and now the patient's breathing bigger tidal volume breaths than he was an hour ago. Well, good, the patient's doing better. He's getting stronger. He's waking up more. So let's drop the pressure support down some more. Let's drop it down to 8. And we're dropping our pressure support down to where we get to a level to where we can say, hey, we can pull this tube. The patient doesn't need the vent anymore.
Because he's breathing on he's got his own, he's breathing on his own.
Yeah. Now, if we really wanted to do it, we would come down to CPAP with pressure support, and that would be totally breathing on his own, because we wouldn't even have those machine-driven breaths at all. You'd take all the machine-driven breaths completely out, and you would only have pressure support.
Okay.
But SIMV is kind of in between. You still have some machine-driven breaths, although you can drop them down a lot. And then CPAP, you completely get rid of the machine-driven breaths. Okay, but don't be fooled. These are volume breaths. Each one of these big ones are volume, just like the assist control breaths. And these are pressure control breaths. All the way through. So we're kind of marrying assist control with CPAP in one sense, and we're also marrying volume control with pressure control in another sense with SIMV.
Okay, that's why it's so popular.
Yeah, and know that I'm just kind of giving you generalities. It really isn't pressure control. I'm not setting an I time or anything like that, but it has the characteristics of pressure control. with those breaths because it has a variable flow and we're setting a pressure with what we want it to achieve.
Okay.
Okay?
Mm-hmm.
Any questions at all with that?
No.
Okay. Tamisha, do you have any questions that you'd like to ask? She may not have her microphone on.
There he goes. Not at the moment.
Okay. If you do, just feel free to holler and we'll get to it.
Okay.
Okay, let's see where we are. Okay, so we talked. You won. Okay, you were asking. Denise was asking about mean airway pressure, plateau pressure. Okay. Let me think here. If I have, let's see. Four boxes. And this one has 2 marbles in it. This one has 4 marbles in it. This one has 4 marbles in it, and this one has 2 marbles in it. What is my average amount of marbles per box?
Two.
2.
Nope. Okay, we're going to go 2 plus 4 plus 4 plus 2. So we have 6 plus 6 equals 12. We have 12 marbles. We're going to divide it by 4 boxes equals 3. Our average is 3 marbles per box because I could take this marble out and put it in here. And I could take this marble out and put it in here. And that would give us 3 marbles per box.
Okay.
Do you guys understand that concept?
Mm-hmm.
Mm-hmm.
Okay. So it doesn't mean that all the boxes have 3 marbles in them. They're different amounts of marbles per box. But the average is 3 marbles per box. Okay. Now, we have a person that's breathing. And let's say this is a PEEP of 5. And here's 10, 15, 20. Okay, here's a breath. And this is 1 minute. And they're taking a breath in. And here's another breath. They're not going to have a very high respiratory rate because I don't have enough room to give them a high respiratory rate on my pad here. Okay, so we have 6 breaths here. And we are going to see what the pressure is at every given time. So if I take this dot right here, and I count that as far as my pressures go, that's 5. And the dot next to it's at 5. And this dot right here is 6. And this dot right here is 10. You see where I'm going with this? And this dot here is 20. I'm going to add all of those pressures all the way through there. And then I'm going to divide them by how many dots we had, and it's going to give me the average pressure for that entire minute.
I would lose all my marbles.
Yes, and there you go. But it's just like the marbles. Okay, but it's not taking just a few dots. It's like taking, thousands of dots along this entire breath. And all the way along, it's just taking the pressure. Every single place, it's giving us the pressure. It's putting that in its memory. And so what we're going to find is the mean airway pressure will be somewhere higher than 5 because it doesn't go below 5, right? It's either at 5 or higher all the time. It's going to be somewhere below 20 because 20 is what it peaks out at. Okay, so let's say, all right, so we go up for a little bit. Let's say our mean airway pressure is right here. And we do it as PAW for pressure airway. And this is what it is. So let's say it's at 12. Okay, that is what mean airway pressure. It's just what is your average pressure for that entire minute. Okay, so there are certain things that I can do to increase the mean airway pressure. I could, for one thing, increase my PEEP. That's a really great thing. What if this was 10? And then we're up here at 15 and 20 and 25. Well, that would increase it because now my mean airway pressure is somewhere above 10, below 25. But even when it's resting down here in exhalation, which is usually 2 times the amount of time as it's in inspiration, well, we're hitting 10 for all of those instead of 5. And then every time I go above that baseline, that's helping to increase the value of that mean airway pressure. Okay, all these lines that I'm putting in these breaths is showing you that it's increasing the mean airway pressure above what the PEEP value is. Okay, now if I add more breaths, that's giving more time above baseline. That increases my mean airway pressure. If I put in bigger tidal volumes, well, that brings it up even higher for that duration of time, and that helps increase my mean airway pressure. Does that make sense?
Yeah.
Okay, so where was I? Okay, so to oxygenate, you need to increase the FiO2 and or the mean airway pressure. Okay, so we know that increasing the FiO2 should help us oxygenate better, right? Unless we have a major VQ mismatch and it's not getting where it needs to go. But FiO2, that's a no-brainer. Okay, we just talked about increasing the PEEP. That increases our mean airway pressure. Increasing your tidal volume increases your mean airway pressure. Increasing your respiratory rate increases your mean airway pressure. Increasing your I time does too. If we have a breath that goes in like this, or we have a longer I time, so we have a breath now that goes like this and then holds it over here and then goes down, you can see that I have more area above baseline there than I do there. So all these dots all the way through are high in comparison to the dots in number 1 over here.
The only bad thing is that they don't have these little drawings on the test.
I know, that's true. That is true. But hopefully you'll be able to remember them in your mind.
Yeah, no, that's exactly what I was talking about. Like you said, to increase the oxygen, I mean, to oxygenate better, you would increase the FiO2. And then when you said the mean airway pressure, which is the PAW, I mean, that makes sense. Now that I see it, it's like, no, that makes sense.
Good.
Your PEEP and your PEP, and I mean, yes.
Excellent. Okay, I hesitate to tell you this one, but I'm going to anyway. It's just usually not going to be the answer that you're looking for the test. But if I have 2 breaths and one goes in like this versus one that goes in like this, okay, this is a slow flow, and this is a fast flow. They both get to the same tidal volume, but you'll see that you have more space above the curve with a slow flow than you do the faster flow. So with the mean airway pressure, the whole purpose is to increase the average pressure throughout that whole minute. It's to get it higher above baseline. That's how you increase your mean airway pressure. And that's how you oxygenate. Okay? And when we talk about this, we're talking about VQ mismatches. So if you have an airway coming down here and you have an alveoli, okay, versus an airway here with an alveoli that's atelectatic. Okay, here you can get your O2 in here. Here you're not going to get much O2. And as long as you have perfusion going around both of them with the blood and capillaries, this one right here, number 2, will oxygenate better than number 1. Okay, so what we do, especially with somebody who has, say, atelectasis or whatnot, if we increase the mean airway pressure, that's going to help number 1 expand more and become more like number 2. And that way we will oxygenate better. Because even if I have 100% FiO2 coming into number 1, it's not doing any good if it can't get the alveoli open and help the gas go into the blood.
As a matter of fact, that would probably hurt them.
Yeah, we wouldn't want to do that, because remember, with your ventilator, you're going to go up to 60% FiO2, and if you're still hypoxic,
Then you're going to increase your PEEP.
yes, yep, then you're going to increase your PEEP, and that's why you're going to increase your mean airway pressure, which is going to open up your alveoli more.
Right.
Okay.
Yeah.
All right. This has been an interesting lecture today. This has gone different paths than what I was expecting, and I'm really happy about it. Because
Well, I'm glad, because this is the stuff I have problems with, and I needed help.
yeah. Well, to be honest with you, I don't really care what we talk about on these lectures. It's all going to be stuff that helps you.
Right.
But I would so much rather go down the avenues that you guys want rather than what I have on my PowerPoint slides, just because I think that's what we should talk about next.
Well, after taking it,
So,
the test 5 times, I mean, it's like, okay, something here on these ventilator, on the ventilators aren't, I'm not jiving it. I mean, and it's like, I've got to pinpoint what it is so that I'll recognize it and I'll get it.
yeah.
So that's why it's like, okay, you got to put it in some kind of layman terms here, because
Well, hopefully this will help you get there. And you guys really just keep asking these questions. This is great. I don't really care what we talk about. So.
Okay. I do have a question.
Okay.
Now, as far as if the person needs to oxygenate, you increase the FiO2, and then it doesn't work, increase your PEEP. But as far as the mean airway pressure, does that automatically increases when you increase these others here that you have listed on this slide?
Yes, it does.
Okay.
It boils down to complete physics. It just is what it does. It's like if you hold a rock and then you let go of it, it's going to drop and hit the ground. Not because you think it should or not because you want it to. It's just that's what physics does to that rock.
Okay.
And so when you increase your PEEP, you are going to see your mean airway pressure rise.
Right. Okay.
So, Tamisha, are you working at a hospital or anything right now?
Yes, I'm like in my last rotation for my clinical rotation, the internship at Natchitoches Regional.
Okay.
So I'm getting ready to approach graduation this month, the end of this month.
Okay. And Denise, you are not in a hospital though, right?
No. I quit working last year.
Okay. Okay. So Denise, I wish that you could do this, but you won't be able to. But Tamisha,
Mm-hmm.
I have homework for you.
Okay.
Okay. What I want you to do, I want you to write these things down that are on the screen.
Okay.
And then I want you to go to your preceptor,
Mm-hmm.
and I want you to put a lung on a ventilator, just one of those portable lungs that you can put on that expand and whatnot. And I want you to go in, and you can just go into a volume control if you want. It doesn't matter, whichever one you're going to do. But I'd probably do some of both, some with volume, some with pressure, so you can see the differences with how they do it. I want you to play around with the flow, because you're going to see that the flow is consistent. It's always the same with volume control. It's whatever you set it at. But the flow can change with pressure control, with whatever you want. And you can, squeeze the balloon and help pull the balloon open faster and whatnot and see the differences. And then I want you to adjust every one of these things except the FiO2. You're not going to see anything with that.
Okay.
But what I want you to do is on the ventilator, what kind of ventilator do you use?
The V.
The Avia?
Yeah.
Or okay, it's not the 840 or anything, right?
No.
Okay. So on the Avia, you can go to the screen where you can put all the parameters in, if you, where you can see them going across the screen like that.
Yeah.
What I want you to do is I want you to look at the mean airway pressure.
Okay.
And I want you to just set at whatever settings you want. Set it for a normal patient.
Okay.
And then I want you to adjust the PEEP up and down. And I want you to watch for 20, 30 seconds with each of these changes and see what happens with the mean airway pressure.
Okay.
And then drop the PEEP back down to where it was, let it come back to where it is, and then increase the tidal volume and go down and change all of these parameters here. And watch what happens to the mean airway pressure.
Okay.
That's going to help you a lot, because not only are you going to be talking about it, but you're going to see it in action. And you're going to say, oh my goodness, it just does it. It's just what happens.
Okay. And I must say too, with the ventilators, I'm more comfortable with the volume control modes than the pressures. I mean, I kind of got the concept of pressures, but like when I'm actually trying to do it, or like you say, just working with a practice ventilator in a lung, it takes me a little bit to get used to the pressure control mode.
Okay, and that's completely fine. That's natural, because it is a different way of thinking about it. But when you are, find another blank screen here. When you're in volume control, you're going to have respiratory rate equals, let's say, 10. Tidal volume equals, let's say, 500. PEEP equals 5. You're going to see what the IE ratio is. You're not going to set the IE ratio.
Right.
You can't set the IE ratio on volume, but you can affect the IE ratio depending on your respiratory rate and your tidal volume and your flow. But let's say IE ratio is 1 to 2. Let's just do an ideal one. Okay, so you have these parameters in your volume control. When you want to switch to pressure control, that's fine. You can do that. So you're going to say respiratory rate equals 10, because we're at 10 over here, right? We're just going to mimic it. PEEP, we can say PEEP equals 5. We're not changing that. IE ratio, you can see what the IE ratio is over here. So you can set the IE ratio to 1 to 2 if you want. And that gives you the same IE ratio. Now we're stuck with tidal volume. Well, guess what? On our Avia ventilator, it tells you what the peak inspiratory pressure is. Let's say peak inspiratory pressure equals 22. And we didn't set it in volume because you don't set the pressure in volume, but you can still see what it's getting. You can still see how much pressure it takes to get that 500 cc's in. And if the peak inspiratory pressure is 22, set the peak inspiratory pressure at 22. And that gives you, and then FiO2 stays the same. That gives you a good place to start when you switch over to pressure control.
And then at that point, depending on how the patient reacts to that and like blood gases, that's when you would start changing anything if you needed to change?
Yes. So at the very first, when I set this patient on pressure control, I'm going to put them on those parameters and I'm going to see how they're doing. what is their return tidal volume? Because even though I've set pressure, remember, it still tells me how much tidal volume they're getting.
Right.
Okay. What'd you say?
I said right. Yeah.
Okay. It's going to tell us what their I time is, what their E time is. Because remember, with pressure control, you can set either the IE ratio, or you can set the I time, or you can set the E time. It doesn't matter which one of those you set. Okay, so I told you to set the IE ratio just because that's easier to see. You know, it was 1 to 2 here. You can set it 1 to 2 here, and then start tweaking from there.
And now, is this like if you did a blood gas and say their CO2 was high, and you needed to blow some of that off at this point? Is that when you would redo your peak inspiratory pressure?
Yep, you would either adjust the respiratory rate or the peak inspiratory pressure, depending where the patient is. So, and I can't tell you which one you're going to do because it depends where you are on that scale. If you're already the high respiratory rate, well, you might want to consider going up on the tidal volume, or meaning the peak inspiratory pressure instead.
Right. Usually
or vice versa.
Okay. Okay.
But yes, you're right. You're completely right. If you have high CO2s, you need to either, back to Kevin's golden rules, you need to increase minute ventilation. And you do that by increasing respiratory rate or increasing tidal volume, or both. Both of those have the effect on the minute ventilation.
Okay.
Now I have a question. Now with like I say, at the facility that I'm at, I'm used to always having patients in volume control, but if there are times that they're getting switched to the pressure support. Pressure control mode.
Well, pressure support or pressure control?
Pressure control, I'm sorry.
Okay, no, that's all right. I'm just making sure I'm following you.
But I really don't get the concept when I think it's best to switch them there to the pressure control mode.
Okay. So sometimes it's personal preference. Some physicians like pressure control better than volume control, and vice versa. But pressure control, and this will be really important on your test, when you need to get into a lung protective strategy, meaning here we have a patient and they are turning into ARDS type patient. Okay, with ARDS, you have very low compliance. Their lungs get really stiff. They're hard to expand. And what happens on your volume control, to maintain this tidal volume of 500 cc's, you're going to see your peak pressures go from, 22 to 26 to 28 to 30 to 35 to 40. You see what I'm seeing here with this trend? Well, we know when we get above 30, this is dangerous. And so what we do then is we say, we're going to switch from volume control to pressure control. And I'm going to set my peak inspiratory pressure, let's say at 30, because that's about as high as I want to go and be safe. And we're not going to go above that. So what that does is it protects the lungs from blowing a pneumothorax, because it's going to limit it at 30 for its peak inspiratory pressure. However, it doesn't come without a cost. What we find out when we do that is our tidal volume goes from 500 down to 450, down to 400, down to 350. You see what I mean? Because the lungs are getting stiffer and it's putting in the same amount of pressure, but the lungs, because they're stiff, can't hold as much volume with that same amount of pressure. And so we realize that the CO2s are going to rise. But we're still going to maintain this patient. The patient's going to be really sick for a while. And we can also maximize our respiratory rate, because on this patient, if you have a normal patient, you have a breath that goes in and then they come out and they exhale like that. So you have one part inspiratory, 2 parts expiratory, and that's a normal patient. If you have a COPD patient, it needs to be more like this. 1 part inspiratory, so let's say 4 parts expiratory or so. When you get into an ARDS patient, it's more like this. You want to go in slow, and then they exhale fast. Okay, now think of this as a brittle balloon. If you have a brittle balloon and you have to blow it up, no matter what, that's your requirement. You have to blow it up. You are going to blow in nice and slow. You're not going to just slam the air in because you're going to break a hole in it real fast.
Right.
So you're going to put the air in really slow, but because it's brittle and it's wanting to collapse, not because it's brittle, but because it's really stiff and wants to collapse, the air comes out fast. And so what happens is you can increase your respiratory rate, and you can go into inverse IE ratios, meaning you're taking a longer time for inspiratory than you're taking for expiratory. So that's kind of it in a nutshell, Tamisha. But if you can email me, I will send you copies of the lectures that we've done before that talks about this in greater detail. So do you know what my email address is?
Not by heart, but I have it on my homepage in my announcements.
Okay. Just make sure you do, because first of all, I won't know your email address, but I have so many students, it's hard to remember what I tell one versus another.
Okay.
So make sure you email me. I want to get these to you.
Okay.
And it's going to help this make more sense, because we do spend more time talking about this exact stuff right here. Okay, but when you have pressure, when your compliance is getting worse and your peak pressures are getting higher, you would want to switch to pressure control so that you can protect that lung.
Okay.
Really important for you to know that for your test. Okay, let's talk about, I wanted to talk to you about compliance, because this will be on your test too. And it's something that is really quite easy if you just know what to do with it, and it'll help you get some extra questions correct. First of all, back to the golden rules, you'll see ventilate, you have increased tidal volume and increased respiratory rate. If you need to oxygenate, but you don't need to ventilate better, you're going to pick one of these things that are in white. Okay, and probably not that. Okay. But you're going to pick one of those. If you need to ventilate, you're going to pick one of these two. But if you're back to the oxygenation problem, you have to oxygenate and ventilate better, you need to pick one of the ones in red, because those are the same on both. These two are the same as these two. And so that's how you can fix both problems.
Both problems in what? I'm sorry, I missed that.
So you'll notice that to oxygenate better and to ventilate better, both of those things that are in red on the oxygenation are the same as what is down here with ventilate. And so those they share in common. And so if you need to oxygenate better and ventilate better, you're going to want to pick one of those two that are in red, because that affects both oxygenation and ventilation.
Gotcha. Okay.
Okay?
Yes, that is on the test.
Yes. Okay. Dynamic compliance versus static compliance. So we have our normal breath here, but I'm going to draw our peak pressure and then our plateau pressure. Dynamic is when you have airflow. That's your peak inspiratory pressure. That's what it's dealing with, is your peak inspiratory pressure. Static compliance is dealing with your plateau pressure. Okay, airflow no airflow. And so I'm going to put in parentheses, this is the lung. The static is the compliance of the lung. It doesn't get mixed up because of airflow. It just says how much pressure does it take to keep this volume in the lungs. And the equation to find out compliance is compliance equals volume over pressure. So dynamic compliance equals tidal volume over PIP minus PEEP. And static compliance, which is the one that we usually do, equals tidal volume over plateau minus PEEP. So you can see it's the exact same equation for both of them, with the one exception that we're using peak inspiratory pressure on one and we're using plateau pressure on the other one.
I'm sorry, before you go any further, can you go back to the previous slide? Because I missed the one about what you need to, yeah.
That one?
Okay, because increased. Okay, thank you.
My pleasure. Okay, so we are going to talk about compliance for a minute here. So let's see. All right. Let's see what we have. We have peak inspiratory pressure. We have plateau pressure. And we have the difference between those two. Okay, and this is, let's put another one here. Let's go like that. So here's sample number 1, sample 2, and so forth. If we have a patient, this is our baseline. Okay, they have a plateau pressure of 20, and they have a peak inspiratory pressure of 23. What's the difference between those two numbers?
3.
Okay, 3. You're going to be old hat at this, Denise, aren't you? This is
Well, it's
awesome.
still confusing though when you're sitting there in your little cubicle. I mean, it's,
Yeah.
I know I miss it every time. I mean, I know this is stuff that I miss. That's why I'm like, oh no, this is great.
Okay. I'm going to write some stuff up here. How is the lung doing? That's going to be answered by this. Airway resistance. Is going to be answered by this. Okay. We are doing ventilator checks on this patient, and we just did that baseline. A couple hours later, we come back, and plateau is 22, and peak inspiratory pressure is 25. What's the difference between the two?
3.
3. Okay. Is this patient getting sicker or better? And is this patient's airway resistance increasing, decreasing, or staying the same?
Repeat that again, because I think he's staying the same because of the difference.
Okay. So you think the airway resistance is staying the same? Is that what you said?
Yes.
Okay. And do you think the patient's getting sicker better or the staying the same?
He's getting sicker.
Okay. And you're correct on both of those. Okay. Tamisha, do you know why that's the case?
Not really, but I would have to go with because of the increase in the PIP.
Okay. Not because of the PIP. It's because of the plateau pressure.
Oh, okay.
So when we come back to our equation on compliance, remember it's volume over pressure.
Mm-hmm.
Okay, volume over pressure. So if I have this volume and it's 500 cc's and it takes 20 centimeters of water pressure to keep that in there, we can equate our compliance from that. Now, if I have that same volume and it's 500, but now it's causing me 22 centimeters of water pressure to keep that in there,
Okay.
my lungs have gotten stiffer. So I'm putting an arrow, meaning that the lungs want to collapse more. They're stiffer. Okay, the stiffer they are, the more towards ARDS they're becoming. Does that make sense?
Yeah, now that you demonstrated it.
Okay.
And for that right there, that's why I try to connect it all together. But on your ADR, on your ARDS patients, that's why your tidal volumes are usually smaller.
Yes.
Okay.
Yeah, because it takes it's taken more pressure to get each volume unit in there.
Okay.
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 So, Tamisha, what Denise did is she looked at this plateau pressure, and this is what I do. This is literally the thinking that I do on the test. I'm looking at the plateau pressure first.
Okay.
Okay. And I'm comparing the two. Okay, this plateau pressure has increased. The volume is staying the same in these examples. And so if it's taking more pressure to keep that volume in the lungs, that means the lungs are getting stiffer, which means the patient's getting sicker.
Mm-hmm.
Okay, and if you want to know what compliance is, I sometimes don't want to put it here, but we're going to put it here. So compliance. So this is baseline. This means the compliance is getting lower. Because that's probably what the test is going to ask you. It'll say, here are your values. Is the compliance increasing or decreasing?
Sometimes it has that one diagram that has all of the arrows.
Okay.
Increase, decrease, increase, decrease. What does this, I mean, it's that one that has all the different increase, decrease.
Yeah. Which would be completely fine because you don't have to have numbers here. You can just see, okay, plateau pressure is increasing. That means the compliance is decreasing.
Right.
Patients getting sicker.
Right.
Okay, so this is number one. I'm just going to put a 1 over here to the side. That's the first step that I do. I look at the plateau pressure and I compare it with the one previous. And that tells me what direction the patient's going as far as the health of their lungs. Okay, then I look at the peak pressure, but the only reason why I'm looking at the peak pressure is because I want to find out what this is. I want to look at the difference between those two, because that difference is airway resistance. Okay, if our peak pressure is 25, remember with our breath going in, it goes in like that and then it comes down and then out like that.
Mm-hmm.
Okay, what I want to do is look at the difference between right here, because that is airway resistance. Okay, I don't care what this peak, I mean, I do care what the peak pressure is, but for this example, I don't really care what the peak pressure is as long as I can see what the difference between the peak and the plateau is. And then I'm comparing that with the one before. Well, we had an airway resistance of 3 before. We have an airway resistance of 3 now. That means the airway resistance has stayed the same.
The same.
Okay. All right. So Denise,
Mm-hmm.
I want Tamisha, sorry, to answer this next one. And then Denise is going to tell Tamisha whether she was correct or not. Does that sound fair?
Mm-hmm.
Okay.
Okay. All right, Tamisha. Start with step 1.
Step 1.
And tell me if the patient is getting sicker, getting better, or staying the same.
They're getting sicker.
Okay, is that correct, Denise?
Yes.
Okay, it is correct because this pressure went up.
Mm-hmm.
Okay,
And there's a difference of 4.
okay.
Mm-hmm.
So, Tamisha, is the airway resistance getting less, more, or staying the same?
Air resistance. No, it's not the same. I would say more.
Okay, why are you saying more? Because
Air resistance.
because I can tell by your voice that's a guess.
Yeah.
Okay, it's more just because we're comparing this number. That's literally all we're doing is comparing these numbers.
Mm-hmm.
This is step number 1 right here. This is step number 2 here. But before you can do step 2, you need to see what the difference is between your peak pressure and your plateau pressure.
So you should not let the peak pressure, the PIP, interfere with anything that you're thinking. What we're looking at is just the plateau and the difference.
Yes.
Because a lot of times having that at 27, you're thinking, oh, wow, what's the patient doing? That would throw you off. But in reality, all you really need to look at is your plateau and the difference.
Yeah.
Oh, okay, because that's what I did. Because I was like, wait.
Absolutely. I mean, I'm there with you. I know.
So here is an example that Denise would be talking about. Okay, so first of all, before we do step 1 and step 2, let's fill in the difference between the two.
2.
Okay.
Okay.
All right. Tamisha, is this patient getting sicker, better, or staying the same?
Okay. So looking at the plateau, they would be still getting sicker.
Excellent. Okay. So this patient is getting sicker. Good. You did step 1 perfect. And with them getting sicker, that means my compliance is going down. Okay. Is the airway resistance getting better, getting worse, or staying the same?
It's actually gotten better.
Yeah, because it then went down some.
Okay. Good. It's getting better. Okay. But you notice this peak pressure is 30. It's way
Yeah.
higher than all the rest.
Mm-hmm.
But the reason why it's 30 is because this part right here, this plateau pressure,
Mm-hmm.
is up at 28 now instead of 20 or 22 or 23. So the reason why the peak pressure went up higher, the peak pressure is always going to be higher than the plateau pressure. It follows the plateau pressure. If the plateau pressure goes up, so does the peak pressure. Okay. Now, you can get bigger differences between the peak pressure and the plateau pressure. And when you start seeing that increase in airway resistance, let's say this next one jumped up to 6 for the difference between the two. Well, that lets me know that something is causing higher airway resistance in that patient. So chances are the patient probably needs to be suctioned, or maybe the patient needs to have a bronchodilator, or maybe the ET tube is kinked or in a bad position. Anything like that could be causing the airway resistance. But my first thought is I probably should go see if the patient needs to be suctioned.
Right.
Okay. But I'm telling that piece of, I'm determining it by this column right here. And when you're in a test, they're not going to tell you the difference. All they're going to do is they're going to tell you your peak pressure equals 30.
Mm-hmm.
Your plateau equals 28.
And what they'll do is they'll have different times and
Yep.
say you had a ventilator check at 8, 9, and 10, and they'll have these numbers, and absolutely, that's what they do.
Yep. And so you're going to have to determine on your own, without any coaching from them, what the difference is.
So basically, if we just remember the note that you put up here, the plateau is how well the lung is doing, and then the airway resistance is the difference between the two numbers, we can pretty much answer the question?
Yes.
Yes.
Okay.
And
Yeah.
there's several questions, but they're all written in different terms.
Mm-hmm.
Because you'll have one that'll be across the board and it'll say, we did a ventilator check at 8, 9, and 10, and these are the numbers that we came up with. You know, how's the patient doing? And then you'll have answer A, B, C, or D. But then they'll also put it in a form where you'll have a chart and it'll have like all the different lung compliances. Do they increase, decrease, and what happens? And it'll have like 4 different ones, and you have to pick out what it's doing by the verbal, not just a chart.
Yeah.
They'll do it verbally and they do a chart, and yes, that's how they do it.
Good. So pay attention to the relationship here. If
Right.
your plateau pressure is going up, your compliance is going down. Okay, and that's because the pressure in your equation is on the bottom. Okay, so if I have 1 over 1, that equals 1. If I have 1 over 2, it equals 0.5. Okay, it's getting smaller as the bottom number gets bigger. So as this bottom number, this plateau pressure, gets bigger, the compliance goes down. And a lot of people will get fooled. They'll think, oh, if the plateau pressure is going up, then the compliance is going up. And that's not true.
I did that for like 3 tests.
And that can just kill you because there are a lot of questions like this on the test.
Yes.
So getting this one concept down could be, 5, maybe 6 questions worth of answers that it could
Right.
help.
And when you miss it by 10, it's like, seriously?
Yeah.
I mean, and it's like, kind of like what area. Okay, I know that there's several questions on this. I really need to get this down.
Yeah.
So, yeah, no, this is great.
Okay, well, why don't we use this as our stopping point then? We didn't get into the questions, which is perfect because next time we'll go through various questions that you could see on the test and we'll solve them. That should be hopefully where we take the concepts that we've learned and put them to use. So do you guys have any other questions before we end though?
No, and with this whole compliance and the PEEP and the plateau, now when we take our breath in and we get to the top, that's where we peak out at, and then it drops down. And your plateau, the difference in the compliance is from when you peak till it drops. So therefore, if you're closer together from where you peaked and you drop, you're getting worse because you don't have any distance between that and that resting plateau period, correct?
Wait, are you talking this area right here?
Yes.
Okay, so that's, that area right there is the difference between your peak pressure and your plateau pressure.
Okay.
Right.
That's your airway resistance.
Right. So if it's
not your
closer,
compliance.
so okay, the resistance. So if the resistance is closer together, then you're doing worse.
Well,
Or you can't always go by that.
let me go to a blank page here. Oh, we don't want to do that. That's what we're doing next time. Okay. If you have a peak pressure or breath that's like that,
Mhm.
and one that's like that. This has higher airway resistance. Because this is where you're getting your values. Let's say this is 30 and this is 26. And let's say this stays at 26. Well, this is probably like 28 for peak inspiratory pressure. And so when we bring those down into our graph, we have PIP, we have plateau. So we have 26 for both plateaus. But one of them we have 30 for peak, and the other one we have 28 for peak. So that gives us a difference of 4 and a difference of 2. That's what we're talking about with the difference between these.
Okay, so actually your compliance stayed the same,
Yes, it did.
but your resistance went up.
Yes. Now, I can see what you're talking about. Okay, so let's say we have this, and we have this. Now, if this stays the same, if that's 30 and that's 30, and this is 26, and now this is 28, then that would be showing that your lungs are getting stiffer. Your compliance is getting lower because your plateau pressure is what changed here. Well, your plateau pressure is what increased from 26 to 28.
Okay.
So the difference between the two is airway resistance. Okay, so our plateau pressure is 28, and our airway resistance in this example decreased. It decreased from 4 to 2. If I didn't want the airway resistance to decrease, then I would have gone up higher here, and this would have become 32 to give us the difference between 28 and 32 would be 4. But the whole thing boils down to, that is lung compliance. And this is airway resistance.
Because like if you're on a ventilator and your alarm is going off, say your peak alarm is going off,
Okay.
that is your that would be your airway, right? And so you would want to suction them, or because it being a high alarm?
Yeah, I mean, you need to look at it and see. It could be that their compliance has gotten so horrible that their pressures have gone up, but usually it's because they need to be suctioned, or they're coughing, or they're holding their breath, or they're biting their tube.
Right. Okay.
Any of those things could cause the peak pressure alarm to go off.
Okay. That's okay.
But oftentimes it's, patients coughing and whatnot against it.
Okay.
And then if you get a low pressure, you have a disconnect somewhere. You have a leak somewhere in the system.
Yeah.
Okay.
Awesome.
Thank you, guys. We'll be here next week at the same time, and we'll do our next lecture.
Sounds great.
Okay. Have a great one.
Thank you.
too.
Thanks. You bet. Bye.
Bye.